welcome you to the interaction on frequently asked questions on structural equation modeling part 4. I am happy to have Professor Jitesh Thakkar, who is the author of the book on structural equation modeling, application for research and practice with MS and R, with us for interaction on structural equation modeling. Professor Thakkar is a Dean Academics and Professor in Logistics Supply Chain Management at Gati Shakti Vishwavidyalaya, Central University, Baroda. Dr. Thakkar was a faculty at IIT Kharagpur and has a professional experience of more than 25 years. He is a faculty expert at leading institute, IITs, NITs, and MITs, and others. Dr. Thakkar is listed in the world ranking of 2% scientists by Stanford University. Let us continue in our discussion and evolve a great understanding on structural equation modeling. Begin with the first question. Sir, how do I interpret the model fit indices in structural equation modeling, and what are the commonly accepted and cutoffs are?
Yes, thank you, Archana. We are advancing in our journey, and last episode, part 3, we talked about a couple of important and interesting issues like confirmatory structural equation modeling, exploratory structural equation modeling, and how do I look at the model fit when I have two important elements. One is the measurement model, another is the structural model to deal with. Let us advance in our journey as a part of 4th episode on structural equation modeling, frequently asked question. And your question is very interesting. How do I interpret the model fit indices in SEM? And what are the commonly accepted cutoffs? So fine, you have the measurement model, you have the structural model, but then how do I validate it? I have the hypothesized relationships, and now for the sample data, I have applied my model. Now I should have some measures to see that my model fit indices really indicate the data is really explaining what my hypothesized relationships as depicted, as illustrated in my model. So typically, model fit indices evaluate how well the proposed model, the underlying word is proposed model, proposed relationships amongst the latent variables, observed variables, and so on. So how the proposed model fits the observed data? There is not a single based index. Okay, and couple of recommended indices and their range, as I have also indicated in my book on structural equation modeling, is like this. First is the chi-square. So this is a sensitive to sample size test. A non-significant value, typically we call P greater than 0.05, indicates a good fit, but often rejected in large samples. The second index is comparative fit index. Value can range maybe greater than 0.9 or greater than 0.95. For excellent fit, indicates a good fit of the model for the observed data. The third index is Thakkar-Lewis index, TLI, or non-normed fit index, NFI. So similar to CFI, as I explained, the values could be greater than or equal to 0.9 or 0.95, and this indicates a good fit. The fourth widely used index or measure is root mean square error of approximation, RMSEA. So values ranging maybe less than or equal to 0.08 or less than or equal to 0.05 typically depicts the excellent fit, or if it is less than 0.08, then it indicates the good fit. The another index which is widely used is standardized root mean square, residual, SR/MR, and this index values less than or equal to 0.08 indicates a good fit. If we look at, let us say some example, let us say a researcher is analyzing factors influencing job satisfaction in Indian public sector banks. This researcher would use these suggested indices to determine if his or her theoretical model means work-life balance, leadership support, predict the job satisfaction or not. So whether this theoretical model is adequately supported by the collected data or not, whether my theoretical model exactly explains what it intends to explain when I have used it for the real life data, for the sample data or not. So if the fit indices are poor, the model might need some kind of specifications, adjustments, and you have to revisit your theoretical model, hypothesized relationship among the latent variables, observed variables, and so on.
That really clear ups the fit indices. Seeing this comparative fit index, CFI, and Thakkar LVS index, TLI, along with the root mean square error of approximation, RMSEA, and standard root mean square residual, SRMR, is give the full picture how a model hold up, and understanding why a non-significant chi-square is a big sample make me feel more realistic about the goal. Thank you, Professor Jitesh Thakkar, for breaking down so smoothly. Now begin with the second question. So what are the modification, moderation, and mediation effect in structural equation modeling?
Yes, this is another important domain, and many a times analyst, researcher, they want to understand what is moderation, what is mediation, and what is the difference between these two, and in what way capturing this moderation and mediation effect in your SEM can make your analysis more rigorous and realistic for the context or situation you are investigating. So let us begin with moderation. So even if you go by the dictionary meaning or the interpretation, then moderation refers to a situation that includes three or more variables to examine the association between two variables under the influence of the third variable. So this third variable falls into the category of moderating effect. So this is similar to examining an interaction in ANOVA. So when you conduct the analysis of variance test, you have the provision even to examine the interaction effect. Suppose you are examining pressure, temperature, then even the interaction between pressure and temperature can be statistically validated. Here I can give the example. Say we teachers are always concerned about the learning of our students, and we strongly emphasize on regularity in attendance. So let us say regularity in attending class and student performance in exam may differ at different level of learning motivation. Simply, if I am physically present in the class does not mean that my learning is enhanced. So motivation really plays a critical role, and this learning motivation can be different at different point in time. So this is typically the definition of interaction also. So what the case I have narrated and the example I have given, it means that it is very much possible that regularity in attending the class may have different degree of influence on students' performance, where it is assessed at different level of learning motivation. Today's student is sitting in the class with X level of learning motivation. Tomorrow he is sitting in the class with different level of learning motivation. So even there is a regularity in attending the class, the learning outcome, that is the performance exam, can significantly vary because learning motivation at different point in time or on different days are different. So this indicates a two-way interaction between regularity in attending classes and students' performance in exam. So you may just visually think that you have the student's performance on right side and you have three variables connected through paths. One is regularity in attendance, another is learning motivation, third is regularity in attendance class into learning motivation, that is the interaction. So I can have assessment of the direct impact of regularity in attending the class on students' performance, learning motivation, direct impact on student performance, and the interaction between these two, that is regularity in attending class multiplied by learning motivation, typically interaction effect. And this can help me to really assess the situation in a much deeper way when I'm considering the moderation impact. And yes, I can also compare three different effects independently, that if there is only regularity in attending class, what is the impact on student performance? If there is learning motivation, what is the impact? And if the interaction. So that is about moderation. Let us come to mediation part. So mediation refers to a kind of situation that includes three or more variables with causal relationship between all three variables. Here, I am not going for the independent assessment of maybe the independent variable or the interaction effect. I am having the set of variables which has the causal relationship. So it is necessary to understand that this differs from moderation effect. So in case of moderation, what we discussed just now, we have considered three separate things in the model that may cause a change in the student's performance in exam. And these three things, if I just repeat them, regularity in attending class, learning motivation, and third is the interaction effect of regularity in attending class and learning motivation. Now, if we discuss the mediation part, then mediation describes a much different relationship that is generally more complex. And here I am trying to capture the mediation relationship which considers a direct effect between an independent variable and dependent variable. So there are also indirect effects between independent variable and mediator variable, between a mediator variable and the dependent variable. So broadly, the difference in mediation compared to moderation is that it allows for a causal relationship between regularly or attending the class or regularity in attending the class and learning motivation and student performance in the exam to be expressed. So if we assume that learning motivation is not included in the model and we are just interested to examine the direct effect of regularity in attending the class and students performance in exam, this will give us a measure of direct effect, and you can do it with regression or ANOVA. When your model includes learning motivation as a mediator in between variable, means you are passing through that variable, and that direct effect will change the result of decomposing the causal process into indirect effects of regularity in attending the class on learning motivation, and then effect of learning motivation on student performance. So the degree to which this direct effect changes as a result of including the mediating variable, that is learning motivation in this case, is referred as mediating effect. So in general, if I even go by the dictionary meaning and understanding, it is the mediating process where I am trying to examine the impact of students' attendance in the class on their exam performance when I am mediating through learning environment as a variable. But in case of the previous one, that is the moderating effect, I am trying to consider all three: my attendance in the class, learning motivation, direct impact on student performance, and interaction between attendance and the learning motivation on my student performance in the exams. So I hope this idea is very clear that what is the difference between moderation and mediation effect, and these are extensively applied as the foundation analysis of SEM, and it is very important to understand how to analyze such models, SEM models, considering mediating and moderating effect where the complex structural relationships are involved.
Thank you, sir. Your example is really clarify the difference between moderation and mediation. By framing the moderation is how a relationship shift under the different condition, and mediation as step-by-step chain of effects show the two clear way to explore complex interaction in our data. Sir, begin with the third question. My question is, suppose I am a final year mechanical engineering student. Can I use a structural equation modeling for doing my project in the domain of production engineering, sir?
Yes, thank you for raising an application-oriented question. And one word you used while summarizing the previous question is very good, and I want to re-emphasize on that. And that is the step-by-step chain of effect when you talk about the mediation. So that is very important. Fine. So let us come to your question that you are a final year mechanical engineering student, and can I use SCM for doing your project in the domain of production engineering, or this SCM is only used for maybe humanities, social science, and management kind of thing? So, as I mentioned right in the first episode, the part one, that this technique, SCM, has a huge and versatile application across all domain: engineering, medicine, social science, management, laws, all spectrum. This has wide applications. So yes, you can use SCM, and I will explain you with the example. So you'll think about the organizational productivity because you talked about the production engineering. So certainly when you are doing the production, your one of the critical concern is about the productivity. Productivity could be of human productivity, or it could be the plant productivity, machine productivity, different kind of resources you have in your production facility, and you want to see the productivity, and you can even go for the analysis of total factor productivity. So organizational productivity is governed by many factors which are either observable or maybe the latent. For example, government policies, quality of raw material, technology, whether you are using traditional machine or CNC machines or maybe semi-automatic machines, so whatever, motivation of workers and standardization of the processes. Now, if you look at these 4 or 5 variables, then they may have linear or causal relationship between them. So this can be considered certainly as one of the most potential candidate for structural equation modeling analysis. So if we think about an example typically in the domain of manufacturing process, then impact of many factors on quality of manufacturing process can even be considered as another potential problem which can be studied, analyzed, investigated in a quite realistic manner using structural equation modeling. So I hope my narration, it's not only about mechanical engineering, but you can find set of problems across engineering, medicine, law, humanities, social science, management, different domains. And you can certainly apply structural equation modeling effectively to investigate the causality involved within the model between the latent variable, observed variable, and its impact on the effect which is under investigation.
So it is great to know a structural modeling is not locked into the social science, but your production engineering scenario shows how to juggling with the policies, materials, quality, motivation, all at once. Now I can see how I frame my mechanical project around with the same idea. So thank you so much, sir, for practical insight. Now begin with the last question, sir. Can I missing a data in structure equation modeling analysis like other statistics analysis create a problem, and how do we handling a missing data situation in structure equation modeling analysis, sir?
Absolutely. This is another problem researchers they invariably face, because if they are, let us say, taking some data from the laboratory or survey data, they may find that some data is missing. It may be weather condition data or any other socio-political issues and so on. So here, like any other statistical technique, yes, if there is missing data, it can create a problem or error in the structural equation modeling. And in a more technical way, I will say that missing data can reduce the statistical power or discriminatory power of the analysis and results into poor investigation. So most widely used technique for missing data estimation is maximum likelihood methods, and majority of the softwares, whatever you are using, maybe MOS or R or whatever, these packages are equipped with this method, and that can help you even to compensate for the missing data by having some good estimates for those missing links. So absolutely, it has an impact on discriminatory power, but with the methods like maximum likelihood and other, you can at least reasonably estimate the missing data, and then once you have the complete data set, you can apply the structural equation model.
Missing data is used to feel like a nightmare, but maximally likelihood estimated as sound manageable and robust. Knowing most of the structure equation modeling tools are handling it out of the box give me a confidence, but will not lose the power of analytics or analysis. So thank you so much, sir, for pointing us for that. Now we are concluding that we are covering everything for assessing the model fit to entangle indirect effects, applying how structure equation modeling is engineering context and managing the missing data. This is very providing us with a practical and hand-on toolkit to enhancing our research practices. Thank you so much, sir, for your expert guidance. It's been invaluable and approachable methods. So I'm looking forward to you at our next session, sir.
Thank you, Archana, for assisting this entire series on frequently asked questions on structural equation modeling. So total 6 episodes parts are there, and we have completed part 4. We started with the most basic idea, why SEM and what is its utility, and today we even had a deep dive into the critical issues like moderating effect, mediating effect, missing data, and so on. Few more important aspects we will explore as a part of our next episodes on frequently asked questions on structural equation modeling. Thank you.